Hi, I'm Grace Chan. I'm a first-year PhD student in the Connor Lab in the Eco-Evo Biology Department at UCI. Today, I'll be talking to you about how one small mussel, the California mussel, can shed light on thriving in extreme environments. Global climate change is increasing temperatures around the planet, and this is devastating many marine environments. The intertidal zone is one marine environment that is particularly at stake. The intertidal zone is a section of the ocean that meets the land. There are several different zones in the intertidal, but we'll be talking about the upper zone. This area is exposed to both water and air. The California mussel lives in this zone and are the main focus of my research on thriving in extreme environments. These mussels are important to study because they can shield and provide habitats for smaller intertidal animals, and they are also food to larger ones. Understanding how these mussels are able to withstand global climate change effects may key us into how the community of other intertidal animals may be impacted as well. So as I mentioned earlier, the upper zone is interesting because animals in this zone are exposed to both water and air. When it is high tide, seawater floods the area and the mussels are submerged underwater. They experience cooler temperatures that are closer to their normal body temperature. However, when it is low tide, seawater moves away from the area and the mussels are now exposed to air. The mussels will experience warmer temperatures from the heat of the sun. So this entire habitat is considered an extreme environment because of the large changes in temperature that the intertidal animals must face. And with global climate change, temperatures may be increasing well beyond the normal range. With the drastic changes in temperature, how do the mussels survive this environment? Biochemistry plays an important role, in particular, proteins. Proteins are the building blocks of our muscles, tissues, and organs. They are also key players in other aspects of our biology, such as energy building processes and the makeup of our cells. Proteins are also highly responsive to their environments and are very sensitive to warm temperatures, and that they will actually break down when it gets too hot. You can think of this like ice cream. Ice cream stays cold and solid when the temperature is cooler. But however, as it gets hotter, it starts to melt. This is very similar to how proteins respond to temperature. You can think of proteins in mussels being solid like cold ice cream at high tide, but melted and broken down at low tide. But then how do the mussels survive during low tide when their proteins are basically melted ice cream? Proteins that break down and melt can cause death. However, we don't see this happening in the mussels, and they are actually able to survive despite that. We think it might be partly due to the strength and stability of their proteins. So like an ice cream with the ability to stay cold even when it's hot. Thus, my research hopes to dive deeper into understanding how proteins are able to stay strong and resist breakdown in the California mussel, especially in the context of global climate change and increasing temperatures. And as mentioned earlier, this will all give us a better insight into how other intertidal animals that depend on these mussels may also be impacted by global climate change. Thank you.